on this computer. All right, guys, we left with self join. And let me go back to the script what I've written here. So we have seen ANSI format, which we covered, and we are talking about a non-ANSI format. So this is basically called as a old style of format, which we hardly use in the real environment, because this more or less equi-join and non-equi-join and self-join works like your modern type of formats. But however, the self-join is little different. We'll discuss later. So in this list, we have something called equi-join, non-equi-join, self-join. Okay, let's keep that self-join separately for now. The word itself is indicating what is equi-join means. Okay, it will also try to see the equality condition between the two tables and try to get the information for you. That's it. Now, only thing is I need to know what the query goes in order to get this kind of information. Non-query again, non-equi join, nothing but non-equal values from the both the tables or multiple tables rather will try to fetch the information for you. Now, whatever I'm referring to, that is equi-join or non-equi-join, it sounds same the way I was talking about inner join, left join, right join. But why they are coming under a subdivision? Because they are the non-ANSI format, and the keyword which you are going to use is where clause. Okay, we are going to use a keyword where, but not on. On is a keyword which is used for these joins, and for the equi and non-equi and self join, we use a where clause. Okay, the way we use a select query, select star from table name where employee name equal to something. So this is a select query which you've been using it. Now we want to use in the joins without using on. On is the only keyword which helps us to join from multiple tables. But this is a different kind of set of topic what we are referring. We are still doing the joins, but we are trying to use a where clause here. So let's try to see what is a self join for the first one. The self join is basically talks about joining a table. Okay, before we start this self join, we know joins means always connecting more than two tables. Okay, more than one table or multiple tables. But here the word itself is indicating self join. Okay, self join in the sense it will always work with only one table. Even if you have multiple tables, we cannot work with. We need only one table to join. Now the question is, you're talking about a one table and at the same time joining. How it is possible? Yes, there is a table called A. Let's assume I want to join with the table A. Now little confusion. I have a table A and I want to join with the table A. So that means my main table will try to create some virtual table which is not really existing actually. I have only table called A. There is no another table called A. Okay, we cannot have the same kind of table names or databases as we know. So the table A will try to connect to table A, right? So that means the very first table is my master table. The second table is also a table, but it's not existing. It is a virtual table. That means I'm trying to join a table within the same table. That's how we are trying to fetch the records from your own table. So let's try to see some example, but let's see what it is. Joining a table data by itself is called a self join. All right, so that's the primary thing about the self join. It is little, it's completely different. It's not even little, it's a completely different from what we are speaking so far, always talking about a multiple tables, but this is a simple only one table. Now can use with all right. So as I was saying, table A, which is having a proper name. But what about the virtual table? What name you want to give? I can't give any name there because table A is already there. I cannot say again table A. So we are going to use alias name. As we know already how to use the alias name, that is using a keyword called as. Okay, whenever you put any as keyword before after the column name or after the table name, it becomes a alias name. So giving a short name. So the master table will have its own name. At the same time, the virtual table is going to have a alias name. So we can give as many alias names possible for the columns or the table, because the main strength and source of this self join is only alias name. Without alias name, because in the previous examples, even if I don't use alias name, SQL Server is not really bothered. But when you talk about the self join, it is must to understand how to use a alias name, because we are creating a virtual table which is not really existing. All right. So it plays a very important role that we need to use alias name, and any number of alias names can be given on a single table. All right. And there's no limit as many as, because it's a virtual table we are working for. Next one can be implemented only on single table. All right. So when we compare, what happens is when we compare, let me put this as compare column values within the same table. That's it. This is a main concern about the self join. Joining a table with data by itself is called a self join. Can be used can use with the alias names of the tables. Can any number of alias names can be given on a single table, because that's how we are going to identify the same employee name. Again, I want to refer. So employee name becomes a duplicate. So I want to give some alias name so that I can make them different to use in my table, right? So can be implemented on only single table, guys. This is a very important note. It can be implemented only on a single table. There's no multiple table concept here. So when we compare a column, the values should be within the table only. Obviously, the first note itself says like it is only single table. So obviously we need to talk about a single table. So let me repeat quickly. Joining a table's data by itself is called as a self join and can be used with the alias name, as I said, and the comparing the volumes also within the table itself. So let's try to take a classic example. And the question is, what kind of situations you are going to face in the real world, and what would be the necessity of using this self join? Okay, when you talk about the two tables, it's quite easy. I want to get this data from this table to this table, and I want to see what are the matching records, what are the not matching records. You want to go for some kind of different data model systems there. But here, when it comes to one table only, what kind of situation you may come across? It is basically used to find the relationship, okay, between the data within the same table itself. Okay, so let's assume there is a table where we have a employees and as well as a managers, which is a classic example actually. We have a employees at the same time, we have executives at the same time, managers within the same table, and we want to find the relationship between that, who is reporting to you, okay, and that guy is reporting to whom, and who is the ultimate boss. So these are the hierarchical issues which you can easily resolve by using a self join. Or also, let's assume you have when you know an employee name called Monty, and you want to know what is his salary and who is also getting the same salary, you want to find from the table. That's a very simple, right? Like if you look at the table itself, if you go to Excel and filter who is earning some 10,000 salary, who are the people same as Monty, you can simply filter. But how to work with us within the SQL in order to find out the same person, Monty, who is earning 10,000, who is the other person who is also earning the same salary. So it is kind of a little different. We can use simply very equal to the salary. If you give, you'll get all the list. But when you don't know what is the salary, how you're going to work. So that's a classic example. Let's try to take which will really clear this definition of how to use this self join in real time. Okay, so for that I need to take some tables, so I'm not spending much time. So what I'll do is simply I'll go to the object explorer. Okay, I'm not creating a table straight away. I'll just go to this table and say new table. So the very first one, I want something called ID. It is going to be integer. Then I want a name. Then it should be varchar for me. Then I need something called salary. Then it should be integer. Then I need something manager ID as well. Let's say INT. Okay. So I have four columns here. Basically, I'm talking about ID, which is an employee ID. I have a name. This name is basically all those employees who are working with different levels. Okay. One is executive who is working and who is he is reporting to whom, and that manager is reporting to whom. So we have a different combinations here. Now my task is to find out who is the person who is having a salary, and similarly who is also earning the same salary in the company. I have only one clue, that the employee name is Monty, but I don't know the other guy who is earning the same. So in order to get the same kind of action, let's try to create the data set for this. So let me say EMP MGR, which is nothing but employee manager relationship. So I said, okay, solid existing. Minus. Let's say TBL EMP underscore MGR. That's my table name. Once I say okay, the table is created now. Let's go for refresh and click on the table. You should be seeing, yeah, there's the table. So let me go for edit a top 200. Don't go for the design. Design is where you find the skeleton structure of the table. Click on the top 200 and you'll see it's asking for what data you want to insert. So 101, I want to name something called Monty, whose salary is 8,000. Okay. And his manager ID is 101. Okay. And here I want to go for 102. Let's say Deepa year, and the salary is something 11,000. And here it is 108. Let me quickly fill with some random numbers. I want two persons who's having the same salary. That's it. So 103, we have 104, we have 105, then 106. Okay, let's take 6 employees here. And after this, we have Srinivas, whose salary is like 6,000. This is 109. Let me give the similar numbers first: 104, 1110, 106. Okay. So now I need the names here. And his salary is 8,000. No, not let me give 5,000, 4,000. Oops. All right. So this is my final table, what you can see right now. Okay. What you can see right now, that is, it is, we have a 6 records totally, 101 to 106, and we have some employee names and whose salary is this. Now the only clue what I have is, for example, let me make this 106 as, and salary is 8,000. So intentionally I created two employees whose salary is same, because that is what I want to achieve here. So let me close this. My table is ready. So in order to see that, just call here and say, are we in this right database? That is a very important thing to be check. Now, once you say run, now we have this. Okay. We are getting null here. So let me just go and delete, or you can just delete through the. All right. So let me save it. Yeah. Now, when I run this is what I am going to get. That is, we have 6 employees, and you want to see, I have only one clue in this table. That is, I was told Monty is getting 8,000 salary. Can you please find who else is getting 8,000 in the table? By looking at the data itself, or in my Excel file itself, visually I can easily find out. But what happens in the reality? That is, if you are having some millions of rows where you need to find out this kind of relationship, the person who is earning some salary, which you have the clue, and we don't know what is salary also. For example, let's take as only we know the employee name. Your boss asked immediately, I know this guy, let's just see how much is earning, and equally who is also earning. This is the relationship which you're trying to bring on here. So basically what happens here is, we are trying to join nothing but self join here. We are trying to join by using a self join. So when you're doing a self join, what is most important here? We need only the alias names which is going to help you. Okay, only alias name is going to help you. Normally, if I want to query this kind of a tables, what I do is, let me remove all this because to see very clean way. Okay, so normally what you do is, if you want to find the salary, I would definitely do it where salary equal to, as I know it is 8,000. Okay, if I know the salary is 8,000, Monty is earning 8,000, and equally who's earning the same salary. But here the fact is, I don't know what is his salary. If you know, you would have given 8,000 like this, and smartly you give the answer to your boss. But this is not the fact here. This is not what we are looking for. We want to know what salary that Monty is getting. So here we have a clue, one clue. That's it. So can I say salary here again? What happens if I try to run this? Is as good as trying to give the same data set what you have in the previous selection. So let me run both here. It's not giving me anything new. The reason is we are just saying salary equal to salary. So it's trying to get all the information from your table. Now, here, what is important going to be here, giving a alias names, because alias name, as I said, like I have only a table called table EMP manager. Okay, this is my EMP table manager, and I don't have any other table, and the same table has to be created virtually. Okay, so once you say select star from table name, what you do is as keyword you can use, or else you can skip. Let's say this is E1, okay, as a table name. Okay, now use comma. What I do is simply I'll copy this, comma, use E2. Now what you're trying to do is the same table. Okay, let me remove this. The same table, you are trying to give two different alias names so that you can differentiate the same table as a two different tables. Okay, the very first one you are given as E1. It could be anything, just given to for easy understanding, E1 and E2. Now the same table has been become two tables. Now what we need to be have the where condition where the salary equal to, okay. Now when I say salary, this salary is coming from which table? That's again the confusion here. So let me say salary. Okay. Now I have a two tables. Now the table names are not anymore table EMP underscore manager. It's now it is called as short name E1 and E2. Okay, now I have a even, but this salary is coming from which table? I don't know. Which this salary is coming from which table? I don't know. So in order to differentiate, anyway, we already have even and E2. Before this salary, we know how to give the alias name. So let's say even dot. Yes, we are getting. Then E2 dot. E2 dot. Once you say, we should get the IntelliSense. Now this is what we got. Now let's try to see what this brings us. Okay. Now that somewhat I'm very close to this achieving what Monty is earning, equally I want to see who is also earning the same salary. So when I try to run this again, we try to combine these two tables, that is a single table, and also along with the virtual table. Okay, what I mean virtual table here, ID column is there. Here also have ID. I have name column. I have a name column, salary column, manager ID, manager. So nothing but I'm trying to bring both tables together here in order to start comparing things. Okay, I cannot see myself within the table, so I'm trying to create a replica of the table in order to compare this Monty earning how much and equally who is earning the same salary. So typically, uh, here I need what my boss already given me a clue, that is the name of the employee is Monty, right? So when you know the employee of the name as on Monty, so we are going to use the and condition here, okay, and then we are going to say name. Is it a name? Yeah, name equal to Monty. But again the confusion comes here. This name is coming from which table? Already it started showing an error because this column name is not existing anywhere, right? Because our table names are now to transform to E1 and E2. Now which table it is coming from? Let's say E2. Okay, as this is a virtual table, right? E2 is nothing but the virtual table. Now E2 dot name. Now let's see what happens, because now I have the clue who is the person. Now when I run this, I should be getting who are the people, I mean, along with Monty, who else in the same company getting the same salary. If you have 10 records, you will be displaying all the 10 records. But here, I want to see only, as per my data set is concerned, rather, as per my data set is concerned, we have only two records which have a similar salaries here. Okay, so if you look at this query again very closely, select star from the table, which is the main table. I've given the alias name as E1, and then second table, the same table again, which has the alias name as E2, where E1 dot salary, nothing but the first table, E2 dot salary, nothing but the second table, and E2 dot name, which is nothing but a virtual from virtual table. I'm taking the name called Monty. However, I got the information, but still it looks like incomplete because the same table is copied again and again. That is two, it looks like a two tables. So you know how to do that. So that is nothing but you want to use what are the columns you require. That is first I want ID. Okay. Next we want a name. All right. So after that we want a salary. That's it. So you want what columns? Otherwise, the problem with the self join is always it will try to throw the results from two tables and going to display. That is, whatever the columns you have in the main table, even it will try to show in the replica. Okay, replica table, that is a virtual table. It will try to repeat the data, but it doesn't make any sense like showing the same table in, columns again and again in the same final output, and it's a really confusion, right? So you need to just be very clear what columns you are really looking for and try to project only those instead of trying to show as a two tables. Now, ID, if I leave this ID just like that and try to run, definitely you're going to have error because it's not understanding what ID stands for, which table you are referring. So let me put it very clearly. E1 is my table. That's what I'm trying to tell, the first column. Now, what is your second? That is also coming from my E1, okay, which is my primary table. Let me this. Okay. The salary is also coming from the same table. Okay, that is a E1. E1 is my main table. All right. So that's how we could E1. Okay, that's how we could able to customize the query according to your requirement. Once I run it, you'll see now it has been trying to detach from that virtual environment and trying to show up your main table related information only by just kicking off that other table which is created temporarily. Okay, so basically we can use this to resolve most of the hierarchy situations. This only one single line of query, what you have understood, can be used in a multiple ways. I just took an example. Who is Monty is getting 8,000, who else is getting, or you can say this guy is working in this department, who else along with him is working, who's having the same salary. You can put multiple kind of a scenarios in order to see. And Monty is reporting to whom, Anjani is reporting to whom, Srinivas reporting to whom, and who's the ultimate boss. Try to take some classic examples which works with the self join. Okay, and please do remember self join works only with one table only. And let's try to go for the next one, which is again a very simple join, which is called as a equi join. So when you talk about the equi join, the word itself is indicating what it can do for us. Okay, again, uh, these joins, okay, this join, which is nothing but a self join, is used a where clause because it is coming from a non-ANSI, which is an old style format. The next two joins also, which I'm going to talk about, is it's completely using where clause. There's no on keyword here. Okay, there's no on keyword. So basically, what is equi join? As I said, like the word itself is indicating equi join means it is trying to find some equality condition between the two tables in order to retrieve the information for your reporting purpose. So what are the two tables? Maybe you need to create it. So let's say what exactly this is going to do is it will retrieve the data from multiple tables based on what equality condition or simply equal to, okay, equal to operator condition. The word itself is very clear that saying equal to. So that means what is that equals to mean? This is what equals to mean. Okay, so that says very clearly that I cannot use the following operators. Let me put it very clear, following operators. So that means I cannot use less than symbol, I cannot use greater than symbol, I cannot use not equal to, I cannot use less than or equal to, I cannot use greater than or equal to, I cannot use any of the operators here, or not equal to, less than or not equal to. Okay, these are the operators I'm not supposed to use in the equi-join. Okay, because that's a blind rule for the equi-join. Equi-join knows only one thing. Whenever you use equals to, it will be happy. But when you're trying to use the other operators which are not entertained for the equi-join. So for quickly understand, I need two tables here, which let me create again. So I'm going to a new table here. Let me say as serial number, and the data type is int. Then we have something called the name. Then it is going to be a varchar. Okay, that's it. This is my table A. Let's say this is table A. table A and say okay. Now I need one more table, that is a new table. Uh, let's take serial number again, integer, name, and we have varchar 50. So this is a second table now. Uh, this is a B table. That's it. Now let's quickly refresh this to see if you have these two tables on your system, that is in your database. Now we have a table. Already we have a table. Okay, yesterday's. So once you go for edit top 200 rows, now I want to enter some information. Here, let's say 10, and this is Monty. This is 20. This is Adams, and 30 James something. Okay, there are three employees who's a serial number, or we can say employee ID. This is from the A table. Now let me close this. Let me go for a B table, edit top 200. Now it's so easy entering the data because these are static tables. If you think about a dynamic, always try to export it. Okay, export it. Not even you're going to use in the real time insert query into this. Okay, you'll never try to insert data into tables by using thousands of insert queries. No, let's say 10, this is 20, this is 30. Here we want some names, Wagner, and we have Ellen, we have something called Johns. Okay, these are the names. So now totally we have two tables here. Now what I'm trying to achieve by looking at these two tables, let me quickly see what these two tables stands for. Always try to query the table first in order to get an idea what the tables consist of. This is my A table, which is having 3 rows and 2 columns only. Even if you have a million rows, it's the same case. The thing is, we want to understand the concept by just looking at a simple table. This is two tables now. We can see that the two tables existing in my database. One is table A and table B. Now, what I want to achieve here, I want to implement this equi-join by not using the other operators, which are mentioned on the screen, less than, greater than, not equal to, or less than, equal to, greater than, equal to. These operators I'm not supposed to use because it says it's a equi. So it only goes with this uh, base rule, that is using a equal to operator. Now let's try to see how the query is going to be written if you really want to use equi join and you want to get the data. Okay, equi here, it is going to try to find the equality condition. So what is the equality condition here? What is the equality condition here? That means we have something called serial number, which is a equality condition. So for me, that is the only rule through which you are going to get the data for your table. So let's try to use a select query, but again, I cannot use an on keyword, though it is two different tables, right? So let me start writing the query now. Select, I want to say select star from table, that is A, not this table. We have table A, comma, table B. Okay, so I have these two tables here, from which I want to find the equality condition. Now, when we have these two tables, now what is the condition you want to check? That is where serial number, serial number equals to serial number. But this serial number is coming from which table, and this serial number is coming from which table? Simple thing, that is table A dot, okay, and this is table B dot. Instead of using the table names, always try to use the alias name, which is quite easy. Okay. Now select star from table, that is two tables rather, table A and table B, where table 1 dot your first column, which is a primary reference for you, which is a common column with the same data type with the same values either or different values, doesn't matter. Here I'm taking the serial number and the serial number. So when I run this, you will see that it is going to give me the equality condition. Oh, it is going to find the equality condition in both the tables. Let me try to pull up these tables also and run all at once. Now, what exactly it is trying to do, if you understand the logic, equi-join is very, very simple. Now, the first table I want to observe, we have 10, 20, 30, we have 10, 20, 30, and these are the names. Now, what it's trying to do is equality condition between these two tables based on the common column. What it is trying to get is this is what it is trying to get. Now see the final output 10, 10, 20, 20, 30, 30. I would have taken some different numbers so that we can understand, but this is the equality condition. Based on the equality condition, it is trying to get the output, okay, by using a equi-join. But I'm not mentioning anywhere it is a equi-join because it comes with a where clause. Okay, it's a very simple example, guys. So try to take some different values and try to experiment here. Let's try to do it straight away. I want to change maybe in the B table. Let's edit it and try to put some different value this time. Let's say this is 40 now. The data is changed. Now, when I try to run both the tables, I should be getting some different values. This time I'm running all at once to see what's happening. Now it's not recognizing what is 40 because that 40 I'm not able to find in this first table. Okay, I don't have that kind of a relationship. So obviously I cannot find. So if you look at the final output, I'm more worried about what is matching because it's all talking about equi, nothing else. It knows only one thing, equi, without being checking any other things here. So that's about the equi concept. One example will make it very clear the definition of using a equi operator. Now let's try to see what is a non-equi operator and how different it is going to be. And by this time you might have already understood by looking at the equi how the non-equi is going to work. Excuse me. So guys, here, as we are referring that we cannot use anything apart from equal to operator. If I say less than, okay, I want to find it is less than or not. Okay, what kind of information you're getting? This is not what we expected to get, right? So even though it is allowing you to use all those operators which are not supposed to use, it will give a different results which is not relevant to you. Okay, always try to use only equal to operator because this being a equal to. So if you try to use any other operators, it will not be called anymore as your equi-join. Now this is a perfect example of equi-join. Let's go for a non-equi-join. I'm taking the same example again. So what exactly the non-equi is? Retrieving the information from the multiple table based on non-equal to operator. That means I'm going to use the same concept. Just try to understand the difference. Multiple is based on not equal to, but based on all these operators, and cannot use the following operator that is nothing but you're equal to. So I'm just reversing the concept here, nothing else. So if you're trying to use the same test again, here I'm supposed to use not instead of equals to, I'm going to use greater than symbol. Now by using the greater than symbol, what happens is this is a non-equi. Okay, it is trying to check. Let me put this way. Okay, it's trying to check. Let me close this. It is trying to check what is the symbol operator we use here, greater. So this serial number is greater than this or not. So the first serial number, what is there? 20. Is this greater than 10? Yes. 30 is greater than 10? Yes. 30 is greater than 20? Yes. So that means it's trying to get, being you use a greater than operator, so it is getting greater than. So let's try to use less than now. It's trying to see, is this number, the serial number, the first one, is less than 20 or not? Is 10 is less than this, 20 is less than this, 30 is less than this or not? So that's how it the equal non-equi join is going to work. So simply when you're writing the query, if you're using equal to operator, that is a equi join. If you're not using equal to operator, that itself means a non-equi join. So by using all those operators. All right. So far we are working with the tables, and a single table or multiple tables with a different data types. Okay, based on the requirement. Now it's a time to understand what are views. Okay, view is, let me write some notes here so that you can really follow along. View is nothing more than a saved query. The single line statement, which is making us understand view is nothing more than a saved query. That means there is a base table of your company, and out of which you want to create a view. Now the question is, you have a table, why you're not using directly there? Why you are trying to use a view? Okay. Assume that I have a base table in the organization and everybody is trying to access the main table, which will definitely slow down the performance because different people from different parts of the world trying to access the database. And that's my main table. I don't want it to slow down. So what we can do is we want to create a particular piece of that table, piece of information from that table, and start using for your reporting analysis. Okay, so that means my main table is intact without any changes. I'm trying to take a copy of it, maybe the whole table or a part of the table or part of some few columns only or a few rows only from the table, which is specific to my process. Not the entire table is my requirement. Maybe it has some confidential information which I'm not supposed to look in. So what the SQL developer is going to do is he is going to create a piece of table from the main base table, so that you will not interact with the main table. You will be working with the only the view. The view is nothing but, we can think it of a virtual table which is not really existing. Okay, view is nothing but a virtual table which is not really existing. It is also called as a logical table. Okay, it is also a logical table. So the advantage of views is one simple thing, the benefit of then tables is of course view is a basis of, view is created on the basis of table only. So we need to have must and should a table. On top of it we are going to create a view, and this view, unlike table, not going to store any space on your database server. Okay, it is not going to store any space. It is just going to save as a query. Okay, query, so that means it's in kbs, not in mbs or gbs. If my if my main table is like 1 GB of table, I'm trying to create a view out of it, so that I'm ending up a data with only 1 KB. That means only the query I'm saving, but not the original table itself. So guys, remember, this view is nothing but a virtual table or logical table, which is not really existing. Okay, so let's try to take a look with an example, which will try to clear our definition, what exactly it is and how to create it. To create the view, we use a create statement. Okay, we use a create statement. Okay, the way use, I mean, if you want to create a table, how we use a create table. Okay, if you want to create a database, you'll use as a create database. If you want to create a procedure which you haven't started, procedure. Okay, in the same way, when you want to create a view from the original table, so the base thing here is, when I want to start working on a view, I need to ensure there is already a table existing in the real world for my business needs. So create always helps you to create something object. Okay, so far we have seen database, then we have seen table. Now I'm trying to create a view. Okay, so when you start saying that create view, we need to always prefix the name of it. For example, the table, whenever you're creating a table, always we need to prefix with table. Okay, table and table name, for example, employee. And if you are trying to create a view, we need to use a v as a prefix and use employees. Now, why I'm so particular using tbl before the name, v before the name? Tomorrow, if I'm working on the procedures, we store procedure as employee. So all the names are same if you look at employee, 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 but how I'm differentiating each object is, before that I'm giving a what do you call prefix, that is sp, v, tbl, in order to make them differentiate. Okay, here the v stands for a view. Okay, so here if you want to create, if you follow the right naming convention, you can tell what type of object it is. Example, as I said, like tbl is a table object, view is a v is a prefix which I use for the view. That's how we are going to use a prefix name so that we can easily identify. Now, the question is, when you create a view, is it from only a single table or multiple tables? Okay, let's try to differentiate these views again into two parts. One is a simple view, and second one is complex view. Okay, now what is the difference between simple and complex view? Simple is something when you want to create a view from a given table, one single table, then it is termed as a simple view. When you are talking about a multiple tables, maybe my requirement as an end user, I want to have a table of combination of finance and as well as sales related or HR related combination. I want to see a final output. So what basically you going to do is you are going to create a query of joining. Obviously, when you talk about more than one table, we need to create a join there. So you are going to create a join, then you are going to create, and you will hand over a view, final view to me so that I can start using. Okay. As an end user, you expect me not depend on the main table. Okay. Which is the main source for your organization. So one is a simple and one is a complex. Let's see what is both. Now here I want to create a view. For that we need to use any prefix that is v, and let's say employee as just like as a name of the object. Okay. After that we need to use what exactly you want to create, from which table you want to create. So for that matter, let's say select star from, or any particular columns you want to refer, you can also refer. So let's try to see if you have any table that is having some information. Let's take any table for that matter. Okay, we can take any table. Let's say this table. What is there in this? Select star from this table. So when you run this, okay, we got this information from table A. Now select what we have is EMP ID. Then comma we have ename. These are the only two things which I want to show to the end user, because I don't want to project what is the salary of my employees. Maybe. Okay. Then I want to say table A. Okay. This is what you simply created. Select EMP ID and EMP name from table. And is it table A or not? Okay. All right. So it's working. So this is simply I'm trying to select something from a table. Then I want to create a view for this, which is actually not a table, but it is what it is trying to do is it is trying to select the data from an existing base table, which is my main source for my organization. That's a table A. When I run this individually, first always try to run what you're trying to insert in the view. First, see if it is working. Then what you can do is simply select the whole process, what you created. To create the view, as I said, create view, whatever the view name. And once you run it, you'll see that what happened. All right. So whenever you the skeleton, let's try to understand the skeleton first. The create view command goes like this: create view name. We need to use as a keyword, because the select query which you're trying to combine here, which will become the alias for this. Then use your select statement. Okay, that's a simple view which we are trying to create from the existing table. So let me try to create now with a create command as keyword. You can use it anywhere, maybe here or maybe here, doesn't matter. Okay, so once you create a view like this, try to run by selecting the entire procedure, and it will simply say the whenever you're creating a table or whenever you're creating a database, it will simply say the command is successful. Now let's try to refresh my database and try to go for a tables, and you'll not find anywhere. The problem is this is not a table, right? So you'll not find anywhere. Okay, but somewhere there is a folder called views, and let me see if it is existing there. Okay, now you can see DBO, which is a database object, v.employees. Now my question still remains same, as you are keep saying it's a virtual table. Does it have the columns what you created from the original table? So what is the original table actually? The original table is, this is the original table. Let me put star in order to see all the columns. I have 3 columns here, but actually as per the business needs, I'm not supposed to show the salary column. So what I'm trying to do is I'm trying to create a simple view with the only required columns as the salary is the compensation. So let me run this again. You'll get into an errors, because a view which is already created and you're trying to recreate again. So you cannot create with the same names, right? So we have the alternative. We'll see that, but this is how the view is created. Now I want to see how different these both the tables. Okay, select star from view. Okay, the first thing is we can query the table the way we query the table, select star from table. In the same way, we can also query the view. So let me run both and see what happens. It is trying to give the same thing, right? So that means there's no difference. The only difference is I'm trying to hide that salary column from the view because the person who's using is not supposed to access my salary column. So this is a simple view which he can use going forward. Now the thing is, whenever the main table updates, the view will automatically update because there is a query behind that, that is create view. Okay, this particular view will be put it in the scheduler. So by the admin, what he does is, like, whenever there is a small change in the database, even a small thing is updated or the uh, record is deleted, it will be instantly, this view also updates and you'll get the right information into your view. So that means view is like as good as a table, but which is not existing. It's only storing what? It is storing only a saved query. So that means it is trying to store only the query, nothing else. Okay, it's storing only query, nothing else. So now, as you have seen, like, it is both are acting like, I mean, this is a main table and this is a view, both are acting like that. So my question is, if some end user is trying to insert a record into the view, will it update the main table or not? Or else, if you try to insert some data into the main table, will also show in the second table or not? That's the question here. That means, as of now, I understood I can use select query on the view. Can I also use a delete command? Can I also use a update command on these queries? Okay, on the views rather. Okay, already I've seen how to use a select query because select start from v name. Okay, v employee. Now, if I want to insert a row into this, insert into what is the table, that is v employee, that is a view. I want to insert something into the view as an end user because your job is done. You created a view for me. Now it's a time for me to access it, to create a beautiful reports out of it. But there was a requirement. I want to insert a row as an end user. Can I do that? Let's try to see. So insert into table, then I am trying to use a column name emp id, then I'm using ename. Okay, then close that, say values, then I want to say 1004, then I want to say Ronnie, then close it. Now, guys, try to understand. I'm not inserting into the table. I'm inserting into the query. Query, it is only a saved query. It is not a table, in fact. So when I try to run my insert query, because I already have seen how to use the select query, when I try to run, it is saying you are allowed to insert a row. Is that true? So let me try to run both queries now because I don't know how to access the main table. Okay, I don't have that opportunity of updating something in the main table because I don't have an access. So when I run this both the tables, now what I want to see is it really updated the main table also? Yes, you can see that is 1004, which is Ronnie, whose salary is unknown because I'm trying to update my view. I'm not really sure what are the different columns we have in the main table. So that means insert command is really working in views. So in the simple views, always remember every table is updatable. Updatable in the sense we can use all those queries, that is select query, insert query, update query. So let's try to use some update query here. Update. So I want to say v employees. So what do you want to update? Let's say set uh, ename equal to, let's say this time I want to update with name called Deepa, where the EMP ID equals to 1004. So that means what? This 1004, which was Ronnie earlier, I want to update with a Deepa. Here I know how to use the update command. My question here is, can I use update command on the views, not on the table? Tables, anyway, we know that it can be updated. When I run this, what happens is it's still allowing me. That means this command also successfully I can use on my view. So when I run this, what is happening here? Now Ronnie has turned out to a Deepa, and here on the main table also it has been updated. So that means insert is select is successful, insert is successful, and update is also successful. Let's see if I can delete something. Delete from your V employees. I'm not even touching my main table here. I'm just playing around with my view here. So where the condition is EMP ID equals to 1004. So that means I don't want to see this record. So once you run this, one row is deleted. So that means when I run this view, let me write here, this is table, this is view, right? So when I'm running both, It is trying to show me that record what you deleted from the main view that is also applicable for the main table. So that means, in simple words, the simple views are always updatable. Okay. However, DBA can still put certain conditions if somebody doesn't want to update. There are certain kinds of end users who will never try to do any database operation. They know only one thing: retrieve the data, put it in Excel, and try to do some cosmetic changes and try to create some beautiful dashboards. That doesn't get involved. So that means for those kind of people, the view can be created only for read-only mode. That means only he can read, but he cannot do anything. But then set of mid-layer of kind of semi-developers who wants to update as and when they get a business mail to change something. Okay, so they want to change some value. So without me being interacting with the main table, I'm trying to play with the views. Okay, anytime if you think the data is loaded as an invalid, you can delete it. Or else if you loaded some batch big file, then we definitely DB will come into the picture in order to roll back it. So that is what really happens in the real world. So what I understood is the views are updatable. Okay, the views are updatable. The simple view, what I'm talking about, is updatable. Now, when it comes to complex view, it is not a single table. It is going to be multiple tables. So whenever you talk about a multiple tables, I'm pretty sure we need to use the joins there, because you're talking about two tables and an end user doesn't know how to join that, right? So you, as a SQL developer, you're going to join multiple tables and create based on his requirement. So whenever you pick up this kind of simple project, like somebody is looking for a table, you will start deriving from the main table what are the main columns, and business suggests like what are the columns we are looking for, and based on that, based on all the approvals, we will try to create a view for them and also put certain criteria, so that means certain conditions. So complex views is works on a multiple tables. So you can easily imagine, now being a single table, I'm able to update anything, but being it's a multiple table, that means from two tables, when I get a view as a single view, when I'm trying to update, it will not update. The other two tables, A table and B table, I joined together and created a C table, which is a virtual table called view. When you're trying to update in the C table, it will not affect the A and B. So complex views are not updatable. Okay, it is not updatable. It will be generally given as a read-only mode by joining a multiple table. So let's try to see an example how to work with multiple views here. That is complex views. So when you talk about the complex views, as is as I said, let's think about this scenario like we have some non-IT users, okay, non-IT users in the sense those who are not involved with IT related or coding or something, okay, within our organization who wants to interact with our database still, but IT users, as you know, they know little about joins, okay, they doesn't know how to join a table. Then in that case, what you are going to do is, so you are going to write a join query in order to create a view out of these multiple tables. Then you are going to hand over to the person who is going to really use it. So in simple terms, you are the main key person who is going to help the team in order to create all these views, so that the performance issues should not come across any point of time. As I said, the main base table is not supposed to touch by everyone. It's main SQL developers and as well as DBA only should have an access, and the rest of the things should be a view. So that's why in the live organization, when you get an access, try to check. Uh, More than tables, you'll find only views. Okay, the only single table will be slice and dice according to the business needs and will be created in a different views uh, by using this view command. Okay guys, now it's clearly evident that by using a simple, that means you are going to use only single table. When you talk about a complex view, we are going to use multiple tables. So for that, I need a quick tables. Let's try to create and understand more about the views, because it's going to play a very, very important role for you. So for that, I need to have two tables here. Let's try to create quickly. This is new table. I'm not using any queries here. DPT ID. Then I want some as a integer. Then I want something called DPT name, which is nothing but a varchar for me. Just take a look at what table I'm trying to create and how this is going to help us. So this is my first table called as DEPT. Okay, the table is now created. So let's go back and refresh and see if your table is ready. uh, DPT, right click, go to the edit top 200 because you want to insert a data. Okay. Let's say one stands for something called IT department. This is a static table in my organization, which refers to each department will be coded with some kind of a number, which I'm giving you a simple numbers 1, 2, 3, so that we can easily identify. Second, we have something called payroll, and third, we have something called what about HR, and we have something called fourth as finance. Okay, we have four different departments in our organization whose department ID is this. So if I'm working in any organization, and based on my ID, they will identify which process in which department I'm working for. Okay, so now that my table is created, now closing it, let's always try to check if your table is having the data what you're expecting before you create anything. So my table is ready with IT, payroll, HR, and finance. My table is ready, absolutely. So let me go for a quickly one more table because I'm talking about a complex view. So when you talk about a complex, that means we need multiple tables. When you talk about the multiple tables, definitely for sure you need to use a joins there in order to combine them. And whether you want to create a view or store procedure, that's a later thing, but we need to have some joins between these tables. So let me create something called ID, which is a int, and then what I need, employee name. So let's say name, and we have varchar. Then we have let's say salary, which is going to be int again. Then I want gender, maybe varchar. Then what else you can have, department ID. Okay, that is what we need, more important. So this is going to be integer. Now we know the structure. We have only two columns in the previous table, that is nothing but your department table, and we have something called employee table, which is going to have this kind of column segregation like ID, name, salary, gender, department ID. So let's see whether this ID is going to interact with that one or whether a department ID is. So the ID, what I'm referring ID here means, let's say this is EMP ID rather, so that no confusion. This is employee ID and this is a department ID. Based on this EMP ID, department ID, I'm going to identify each person who is getting salary and whose gender is male or female, working in which department, right? So that is what the kind of simple join which I want to do so that I can start using the. So this going to be TBL EMP. That's it. Now the saved. Let me quickly refresh this. By refresh, go to the tables and see. Oh, what happened? So let's go for a table and see where is your table. That is a TBL. Yeah, TBL employee, that's a table. So always try to check if your table is existing and we have the corresponding data. Okay, now I don't have a data in the second table. Let's try to run quickly and see. Now in this table, let's edit it. So I'm running out of names. So let's try to put some one. Now let me put the serial numbers first. This is 2, this is 3, this is 4, this is 5, this 6. Okay, 6 employees is enough. And here I want to give the corresponding department IDs. So for that I need a names here. So first let's try to consider uh, name as a Monty, and we have salary as 5,000, who is male, and we have Ronnie, whose salary is like 3,400, who is a male again. Okay, I'll put the department IDs later so that we can talk about it. Next, we have something called the third person as Deepa, who is a female, and okay. All right, here we need to provide the salary here, then female. Okay, next we have something called, let's take an example. We have 2 male employees and 1 female employee. And let's take one more, that is Srinivas, who is salary is 5,000 and he is a male. Okay, and then we have something, running out of names actually, Srinivas. And who else we have? Let me check it out from the quickly from here. We have Arya, who is male. And then we have someone called, let's take Ben, who is a male. Let's take a combination of both.